All right, so we're going to try u substitution with some definite integrals. Let's see what happens when we do this. All right, when I look at that integrand, I see that to take the antiderivative, I would need to do a u substitution because it's way too complicated the way it is now. So a good choice for my u would be x squared plus 1. Then my du is going to be 2x dx, which I at least see the x dx in my problem there. Or I could say du over 2 equals x dx, and then I'll just replace the x dx with the du over 2. Or so I'm going to have a 1/2 in the problem, right? So my problem becomes, notice I'm not using an equal sign here, because I'm separating out my work. It's going to become the integral of 1/2 u cubed du. Right? That 1/2 is from my du over 2 over here. And I can take the antiderivative of u cubed, and we would get a u to the 4th. And so a 1/4 will come out front. And I back substitute my u in as x squared plus 1. So my integral from 0 to 1 of x times x squared plus 1 cubed dx is going to be 1/8 times x squared plus 1 to the 4th evaluated from 0 to 1. When I plug a 1 in there, I'm going to get 1/8 times 2 to the 4th. When I plug a 0 in there, I get minus 1/8 times 1 to the 4th, which gives me 15 over 8. Another way I could do this problem is to say it's the integral from 0 to 1 of x times x squared plus 1 cubed dx. My u is x squared plus 1. My du is 2x dx. All of that's the same, but for my limits, when x equals 0, if I plug that in here, that tells me u would be 1. My limits change when I'm in terms of u. And when x equals 1, u equals 2. So I can rewrite this then, when I do my u substitution, as the integral from 1 to 2. So I've changed my limits based on my choice for u, of 1/2 u cubed du, which then becomes 1/8 u going from 1 to 2. So because I changed my limits, I don't have to back substitute. And then we evaluate that. Oops, I lost my 4th, sorry. So I get 1/8 times 2 to the 4th minus 1/8 times 1 to the 4th gives me the same answer as doing it the other way.